Hello. Our goal in this video is first to determine if the improper integral from 1 to infinity of the fraction square root of x over exponential of square root of x is convergent or divergent. If it is convergent, we will try to compute its value. This is a standard calculus problem. The integral from 1 to infinity of 0 dx is an improper integral because the upper limit of integration is infinity. Before addressing the convergence or divergence of this integral, we will first try to find its antiderivative. If we can do so, this will also help us to find the value of this improper integral, by computing the limit of its antiderivative at the end points of the integral. When we look at this problem, it is clear that this is a complex integration question. Whenever you are confronted with this type of problems, it is important to construct a strategy to attack them efficiently. It is always important to analyze the function that we are asked to integrate. This initial analysis of the function will help us figure out the proper methodology to solve the problem. In this case, the fraction square root of x over exponential of square root of x is a quotient of a radical function square root of x and a composition of two functions, the exponential function and the square root function. Because this fraction involves a radical function and a composition of a nonlinear function with the same radical function, it is a good idea to start with the method of substitution. We will perform a change of variable, we introduce a new variable. It is evident that the trivial choice for the new variable w should be the inner function. Thus, west should be square root of x. So, we set west equal to square root of x and dw should be equal to the fraction 1 over 2 times square root of x. The integral from 1 to infinity of the fraction square root of x over exponential of square root of x dx can be expressed as the integral from 1 to infinity of 2 times square root of x divided by the fraction square root of x over exponential of square root of x times the fraction 1 over 2 times square root of x dx. We can clearly see w and dw in the expression of the integral. So, we replace square root of x by w, and the fraction 1 over 2 times square root of x by dw. We then obtain the new expression of this integral as the integral from 1 to infinity of 2w square divided by exponential of w dw. This new expression of the function to integrate is simpler than the original one, however we still have to carefully figure out the best way to integrate this new function. This new function is the product of a polynomial function, 2 times w square, and the nonlinear function, exponential of w. As a matter of fact, the best method for the integration of products of polynomial functions and nonlinear transcendental functions is the method of integration by parts. In this case, we have to use the integration by parts method to compute the integral of 2w square times the function exponential of w dy. Please do not forget to like the video and subscribe to our channel. Thanks to those who have already done so. Let us integrate the function 2w square times exponential of minus w. Remark that, at first glance, we easily see that the function we have to integrate is a product of a nonlinear function, exponential of minus w, with a polynomial function 2w square. Often, when you are faced with this type of complex integration problem, you have to adopt the appropriate strategy that will help you simplify the problem and find the antiderivative efficiently. The two main techniques that we learn in Calculus 2 for solving integrals that involve the products or quotients of nonlinear functions are the use substitution method and the method of integration by parts. The crucial first step of our strategy is to decide which of these two classical methods we should use. In this case, we have a product of a nonlinear function with a polynomial function, so the best method to use is the method of integration by parts. Because this method will help us reduce the complexity of the problem by reducing the degree of the polynomial. It comes that, the polynomial function 2w square is of degree 2. Then, our first goal will be to reduce the degree of the polynomial function to 1, by using the method of integration by parts. Let us briefly review the method of integration by parts. We know that the integral of u dv is equal to u times v minus the integral of v du. In sum, we set u equal to 2w square, so du equals 4w dw. And dv equals to exponential of minus w dw, and v equals to minus 1 times exponential of minus w. Lastly, the integral of 2w square times exponential of minus w dw is equal to minus 2w square times exponential of minus w, plus the integral of 4w times exponential of minus w dw. Consequently, we still have to integrate 4w times exponential of minus w, using integration by parts. Let us integrate the function 4w times exponential of minus w. Given that the function to integrate 4w times exponential of minus w is still the product of a nonlinear function with a polynomial function, we still have to use the method of integration by parts. The main aim of these repeated utilization of the method of integration by parts is to reduce the degree of the polynomial function 4w. Consequently, we set u equal to 4w, so du equals 4dw. And dv equals to exponential of minus w dw, and v equals to minus 1 times exponential of minus w. Finally, the integral of 4w times exponential of minus w dw is equal to minus 4w times exponential of minus w, plus minus 4 times exponential of minus w, plus a constant c. Now we have to aggregate the results of these repeated applications of the integration by parts to get the final value of the antiderivative of 2w squared times exponential of minus w. The first integration by parts gave the following result. So, the integral of 2w squared times exponential of minus w dw is equal to minus 2w squared times exponential of minus w, plus the integral of 4 times exponential of minus w dw. From the second integration by parts, we obtain the following result. So, the integral of 4 times exponential of minus w dw is equal to minus 4w times exponential of minus w, plus minus 4 times exponential of minus w plus a constant of integration c. As a result, combining the last two results, we see that the integral of 2w squared times exponential of minus w dw is equal to minus 2w squared times exponential of minus w, plus minus 4w times exponential of minus w, plus minus 4 times exponential of minus w plus a constant of integration c. In sum, when we replace west by square root of x, we see that the original integral from 1 to infinity of the fraction square root of x over exponential of square root of x dx is equal to the quantities minus 2x over exponential of square root of x plus minus 4 times square root of x over exponential of square root of x plus minus 4 over exponential of square root of x evaluated at the end points 1 and infinity. The next step is to evaluate the quantities minus 2x over exponential of square root of x plus minus 4 times square root of x over exponential of square root of x plus minus 4 over exponential of square root of x at the end points of the improper integral. We will now evaluate the quantities at the end points 1 and infinity. We will then determine if the integral converges or diverges. Consequently, the integral from 1 to infinity of the fraction square root of x over exponential of square root of x dx is equal to the limit as x goes to infinity of minus 2x over exponential of square root of x plus minus 4 times square root of x over exponential of square root of x plus minus 4 over exponential of square root of x minus negative 10 divided by exponential of 1. Which is equal to 10 times exponential of negative 1. This is because the limit as x goes to infinity of minus 2x over exponential of square root of x plus minus 4 times square root of x over exponential of square root of x plus minus 4 over exponential of square root of x is equal to 0. This can be seen by using the L'Hospital rule. Finally, this implies that the integral from 1 to infinity of the fraction square root of x over exponential of square root of x dx converges to 10 times exponential of negative 1. Thank you for viewing this video. Please subscribe to our channel. We have an extensive collection of calculus videos covering limits, derivatives, series, integration and many other calculus-related topics such as probability in differential equations.